Hey everyone, sorry about the unexpected absence here. Let's just dive in and do what we can. Today we're going to be talking about polynomials in context. Our learning target is that I can use polynomial functions to solve real-world problems. And we're going to start with a type of problem that we've seen before, where we want to find the value of x if the volume of the box is given to us. And here we have a box with dimensions x minus 4, 2x, x minus 1, and the volume is 40 cubic inches. Well, you guys, we know that volume is length times width times height. And essentially we can just substitute all of these in. So in for v, the volume, I'm going to put 40. And length, width, and height, they don't matter. You can put them in any order. Because this is a monomial, this 2x, I'm going to put that first. And then I'm going to put the other two dimensions, x minus 1 and x minus 4. Our goal is to find the value of x, so let's flesh this out and get one side equal to 0. So this is one important landmark right here for us to have the setup for the volume. Next, let's get one side equal to 0. You guys know I like to deal with the binomials first. So if I were to distribute x minus 1 and x minus 4, I get x squared. Outer inner is minus 5x. Last is plus 4. I now can distribute the monomial 2x to everything. I've got 2x cubed minus 10x squared plus 8x. And now if I'm going to factor and use the zero product property, I'd have to get one side equal to 0. So I'll subtract 40. And here is my polynomial equal to 0. I have 0 equals 2x cubed minus 10x squared plus 8x minus 40. Now we've talked about a couple different pieces here, but one thing that I notice is that it fits the pattern we discussed for grouping. Notice the relationship between the first and third terms times the coefficient times 4 is the same as the coefficient, the relationship of the second and fourth terms, the coefficient times 4. So that means I'm going to be able to factor by grouping. So I don't need to worry about the whole P over Q thing. I can just do the grouping. But before I do that, one thing I notice is that I can take out a 2 from everything. So I'm going to divide a 2 out of every term, just because that's best practice for us to always take out a greatest common factor. And even after you take out a greatest common factor, you're still able to factor by grouping. I can group these two together and take out an x squared. I can group these two together and take out a positive 4. And let me just fill in everything else, because remember, each line should be equivalent to the one in front of it, or above it. And so then I can use x minus 5 and x squared plus 4 as those factors. And this is the sum of squares, which means I can't factor. So I can then set each factor equal to 0 and solve. Well, we know that if you set x minus 5 equal to 0, we get x equals 5. And if we set x squared plus 4 equal to 0, we get that x squared equals negative 4. And taking the square root, I end up getting plus or minus 2i. So all the solutions of this function are 5 and plus or minus 2i, but in context, this doesn't make any sense. So we're going to X that out as a potential solution here. The question asked me to find the value of x, and so my value of x has to be 5. You should be able to find the dimensions, so we'll just do a quick little FYI over here and talk about what the dimensions would be. So our dimensions would be putting 5 into each of these pieces. So putting 5 into x minus 1, 5 minus 1 is 4 inches. Putting 5 here into 2 times x would be 10 inches. And putting 5 into x minus 4 would be 1 inch. So that's just a little FYI, just because oftentimes we do want you to find the dimension. So I wanted to remind you about that. Okay? We've done stuff like that, and I really like this one because it reminds us that just because we have a cubic doesn't mean that we have to jump to our calculator or use the P over Q, that we sometimes can factor by grouping, and that's fun. So let's move on to example 2. In example 2, it says a company's profit P in thousands of dollars can be modeled by this polynomial. X is the number of items produced in thousands. The profit is $14,000 for producing 2,000 items. What other number of items would produce the same profit? Well, this is asking us what other number of items would also produce this profit of $14,000. And it says that the profit is in thousands of dollars. So essentially, this is telling us that P is 14. So let's put 14 in for P. So I have 14 equals negative 5x cubed plus 6x squared plus 15x. If we are going to solve this, then, or try to find other values of x, then we do often want to use the zero product property and that idea of a function having a remainder of 0. So let's get one side equal to 0. Now, they told us that this 14 occurs when 2,000 items were produced. And once again, it did say that x was the number of items produced in thousands. So this 2,000 items is alluding to the fact that x equals 2. So what that means is that these statements are true when x equals 2. So what that means is that 2 should be a 0 of this function. And if we know that 2 is a 0 of the function, we can take this cubic down to a quadratic and find other values. So because we know this is true when x equals 2, that means that 2 should be a 0 of this function that we have in our second step here. And we can verify that using synthetic division. So let's try to verify that using synthetic division. We're familiar with this process now. We bring down the first number, we multiply, and then we add. We multiply, and we add, we multiply, and what do you know? We get a remainder of 0, as we should have, because they told us that the profit was $14,000 when they produced 2,000 items. So our goal has been completed as far as getting this to be a quadratic. This is going to be negative 5x squared minus 4x plus 7. And because I want to solve, notice that I'm a good student, so I put that equals 0 there. It's easier to try to factor when we get rid of a negative. And so I can factor a negative out of all of these terms, and I end up with 5x squared plus 4x minus 7. The problem is that if I try to factor, if I put 7 and 1 here, that doesn't work. 7 and 1 here, that doesn't work. It's not factorable. But fear not, the whole point of getting a quadratic was so that if it's not factorable, we could use the quadratic formula. And so I'm going to use it on with these values of a is 5, b is 4, and c is negative 7. And let's see what we've got. I know that x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So that means negative 4 plus or minus the square root of 4 squared minus 4 times 5 times negative 7 over 2 times 5. So let's clean that up a little bit that we like to do. The negative 4 is going to be negative 4 plus or minus. I can put this whole thing in the calculator. I can take 4 squared, and again, I recommend you just putting it in just like we do here, 4 squared minus 4 times 5 times negative 7. That gives me 156. and then 2 times 5 is 10. So we've cleaned that up pretty nicely. And if this was an algebraic problem where we wanted the exact solution, then we would want to break down this 156. But because it's a real world problem, we know that we can just put these values in the calculator and come up with some sort of decimal approximation. Because again, this does say about the same profit, so that means that we can estimate. So that's awesome. So let's find out what happens when we add -4 plus root 156 and then divide by 10. That gives me about 0.85. And if I took -4 minus root 156 and divided by 10, that gives me about -1.65. Now remember, X is representing the number of items produced in thousands. So this is 0.85 thousand or -1.65 thousand. Well, goodness gracious, that doesn't make any sense whatsoever, okay? And so we're going to use this 0.85 thousand. Now, you guys, what 0.85 thousand means is that if you don't want to leave it as a decimal, which I wouldn't, that means that you can multiply this by 1,000. So again, because it's in thousands, I'm going to multiply that by 1,000. And if I take 0.85 times 1,000, that gives me 850. So that really means that we can produce about 850 items instead. So I think that's pretty interesting, that if you produce 850 items, you get that profit of $14,000. And then if you produce 2,000 items, you get the same profit. So if you only make your company produce 850, then everyone probably isn't as stressed out, and they'll be much happier. So what a good thing math did for these people in this company. Lastly, we have example 3. And again, this is similar to the problem that we had in example 1, except this time we don't have a picture with the dimensions. You've got to read and figure it out. So this says the prism has a square base. That's probably important. With a height that is 5 feet longer than each side of the base. The volume of the prism is 28 cubic feet. What is the height? So remember that the volume of a prism is length times width times height. And notice it said that there's a square base. So this length and width are going to be the same since it's a square base. Okay? So that square base is important. It's telling us that those are going to be the same. So, and notice it's telling us that the height is 5 feet longer than each side of the base. So this is essentially telling us that my height, if I say that each side of the base is x, that my height is going to be x plus 5. So let's put what we know into the volume formula. So volume, it's telling us in this particular problem, is 28. The square base means that I have 2 dimensions that are both the same. We'll call that x. And then the other dimension that they allude to is the height, which would be x plus 5. So let's flesh this out over here. I'm going to turn this into x squared times x plus 5. I'll then distribute, so the x squared is just from the x times x. I'll distribute the x squared to get x cubed plus 5x squared. And I'll get one side equal to 0. X cubed plus 5x squared minus 28 equals 0. And I want to solve. And so we could try factoring, except this isn't a quadratic. So usually if we have cubics, we factor by grouping if we have more than 2 terms, but we only have 3 and not 4, so that's not going to work. So we get to review what we did as far as the P over Q list. So let's make a list of possible rational zeros. The possibilities for 28 are 1, 2, 4, 7. There's a pair. So then 2 and 14, 1 and 28. And then possibilities for my leading coefficient are just 1. So what we can do is put this in the calculator and see if any of these zeros pop up for us, okay? So I think it's good if you practice getting out your graphing calculators and do this with me, but I don't know, maybe you're just going to sit and make me do all the work, even though I came in on a snow day to record this for you. Okay, so we're going to take x cubed, that means get your calculator out and do it too, plus 5x squared minus 28. And I don't know who used my calculator before me, so I'm going to zoom 6 it to get a nice viewing window. Ooh. And it looks like we have a 0 at x equals 2. Let me check my list. There it is there. So maybe we could try x equals 2. So here, I'll say try x equals 2. And we're going to try that in this polynomial and see if we do indeed get a remainder of 0. Remember, when you set this up, that you have to compensate for any missing degrees. And I do have a missing degree of 1, right? So x cubed, my coefficient was 1. X squared, my coefficient was 5. X, my coefficient was 0. And then my constant was negative 28. So let's see if this can give us a remainder of 0. And it does. Wonderful. And so that means that we now have a quadratic, and that's our goal, is to get to a quadratic, because quadratics are very solvable. The quadratic I have is x squared plus 7x plus 14 equals 0. I can try to factor, but my only factors of 14 are 1 and 14 and 7 and 2, and there's no way the outer inner can be 7. So that's fun. I get to practice the quadratic formula again. So I know that x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And so I get negative 7, and I can clean this up a little bit. So I can take 7 squared minus 4 times 1 times 14. That gives me negative 7 over 2. Now, you know that I like us to solve these out, but for the purposes of this problem, what do we notice about this solution? This is going to give us something imaginary, okay? And because this is a problem in context, in the real world, and we can't deal with imaginary numbers, as soon as you see it's imaginary, okay, but I need to see that. I need to see you get that negative discriminant there. As soon as you see it's imaginary, we can X that out, okay? So what that tells us is that X equals 2, that these other two possibilities are not real possibilities. So notice the question, though, is asking what's the height of the prism. I know that because I read the question. And we know that the height of the prism is x plus 5. And so if I take 2 and put that in, that tells me that the height was going to be 7. And we're measuring this in feet. So our height is 7 feet. Okay? So that's what you guys get to do, is you get to practice some of these methods of solving the different polynomials that we talked about, but in context of the question, okay? That's it. All right, have a great day.